Hello, welcome to this 18th lecture session on database management systems. In this session, we discuss recovery mechanisms for databases. We discuss introduction to recovery, recovery strategies, log-based recovery, checkpointing, and shadow paging techniques for recovery. When a transaction is under execution, it is possible that may leave the database in some inconsistent state. Before the start of the transaction, the database will be in some consistent state, and when a transaction is started and when it is under execution, this may leave the database in some inconsistent state. Once the transaction is completed properly, successfully, then it will definitely take the database to next consistent state. In between, when a transaction is under execution, it is possible that it may fail. As a result of failure of a transaction, the state of the system will not reflect the state of the real world that the database is supposed to capture. We call such state of the database is inconsistent state. When such thing happens, we must make sure that the database is restored back to the previous consistent state which existed before the start of the transaction, that is the transaction which has failed. This process of taking back the database to the previous consistent state is known as recovery process. In this session, we focus on various concepts related to recovery process. That is why a transaction, when it fails, that may leave the database in some inconsistent state. We need to make sure that the state of the database will be taken back to the previous consistent state and restart the transaction. This process of taking it back to the previous consistent state is recovery. If a transaction T performed multiple database modifications, several output operations may be required, and a failure may occur after some of these modifications have been done, but before all of them are done. So that could be the case. In such case, before a transaction performs all the updates to the database, there could be a problem. In order to restore to the recent consistent state, we must first write the information describing the modifications to system log, and where that means system log is the place which where we store all the information related to a transaction under execution and the modifications done by that transaction to the database. Before directly modifying the database, the transactions will have to write the information about the modification onto the system log, and when this kind of system logs are available, this will help us to remove the modifications done by failed transactions. When a transaction is under execution, after each updation, if we have the information about the update operations or the modifications done by this transaction in some place which is called as system log, and then when there is a failure, while rolling back, that is when removing the effects done by this half done transaction will become easy, because we have the information about the modifications regarding the old value of the data item, new value of the data item, the transaction which has modified that, all the information is available. We can always roll back or revert back to the previous state. Now we discuss some important recovery techniques in this session. First recovery technique is log based recovery. That means for in this process, to recover from the failure, we will be using a system log, or we also call it as database system log. What is a log? It is going to we have to enter the various transaction modification related information. Each log record describes a single database write operation and contains the following details: what is the transaction name, what is the data item which is being modified, what is the old value, and what is the new value. When we have this kind of information available in data log, whenever there is a failure with the transaction, using this information we can always go back to the previous state. That means we can nullify or remove the effects done by this unsuccessful or failed transaction. If we look at the typical records in system log, when a transaction is started, this kind of record is inserted into the log. Ti is the transaction, and this indicates Ti is started, and when Ti modifies some data item, Ti is the transaction, Xj is the data item, V1 is the old value, and V2 is the new value. And when a transaction modifies some data item, we will be storing or making an entry related to that modification into the log, system log. And only we need to take care of in the log records only the start, commit of the transaction and the information related to the modifications done by the transaction to the database will be stored. And finally, once the transaction commits, we will be making an entry in the log for the transaction Ti, and it says that transaction Ti has committed. Once a transaction reaches the commit state, it cannot be rolled back. With these log records, we have the ability to undo or redo a modification that has already been output to the database. We have two operations here, undo operation and then redo operation. Suppose let us assume that if there is a data item A and the actual value in the database was 20. Now let us assume that transaction 1 is started. Okay, when it is started, immediately there will be an entry in the log saying that T1 start. And now let us assume that T1 modifies the data item A from 20 to 40. Then we will have a entry T1 modifies data item A, old value is 20 and new value is 40, and then this is modified to 40. And suppose before it commits, let us assume that there is a problem here, that means it has not committed. If it had committed, that means if it is completely done, then it is certain that we will find a record for this T1 which says that it has committed. So this record will be there in the log, but unfortunately before it is committed, there is a failure. Then how to remove? That means once a transaction fails, because of the phenomena or property of this atomicity, all the modifications done by this failed transaction must be removed. In this case, it has modified the data item A and the old value was 20 and the new value is 40. So how to remove this effect? If I look at this log entry, I will understand that the data item A before modification the value was 20. So I will forcibly write this old value here. This is how we can take this database to the previous consistent state, and then once it is failing, it is aborted and it reaches the terminated state, and again the transaction should be restarted. If you have old value and then new value, that is removing the old value, new value and then reverting back to the old value is called as undoing. It is called as undoing. And in some cases we know that the modified value is 40, and then if you don't have confidence whether this modification is properly done to the database or not, in that case you can take the new value and again forcibly write it to the database. That means I am redoing this modification and it may be already 40 and forcibly I am rewriting it to be 40. That means it is called as redoing. And if you redo something any number of times, it is not going to have any effect. Okay, that is the property of this redo operation. I can redo this any number of times, that is 40 can be replaced with 40 any number of times, still you will have the same result. But undoing cannot be done like this. Suppose if you look at this undoing, the original value is 20, after first modification it becomes 40, next it becomes 100, next it is 140, like this. First undo will be restoring the data item to 100. Second undo, if you apply one more time the undo operation, this will become 40, and when you apply undo operation one more time, this becomes 20. So that's why the redo and then undo operations are they have quite different action on the data items, and these two are the basic operations that are required while taking back the database to the previous consistent state. In log based recovery technique, which we are discussing now, we have two approaches. First one is called as deferred database modification approach. The second approach is known as immediate database modification approach. In deferred modification approach, the deferred term itself says that it is postponing something, it is postponement. So this technique ensures atomicity by recording all database modifications or updates in the log, but deferring or postponing the actual updates to the database until the transaction commits. That means whenever a transaction modifies some data item, the modification related information is stored in the system log, but the actual modification to the database is not done till the transaction commits. And as no data item is written before the commit record of the transaction occurs in the log, we need only the new value. Hence, we perform only redo operations in this deferred modification technique. The redo of TI operation sets the value of a data item updated by transaction TI to the new value, and all new values will be found in the log records. Let us have an example to have a better understanding about the concept behind this deferred modification. Redoing, that means in deferred modifications we need only redoing operation. Redoing operation needs only the new value. Hence, if the log based recovery is based on this deferred modification, the modification, that is a record which indicates or represents the modification of a transaction onto the data item, will contain only the new value. It will not contain the old value. Okay, let us assume that I have the transaction, this is the database, and these are the data items A and B and C, and the original value of the data item A is 600, and original value of the data item B is 100, and original value of data item C is 200. Let us assume like this. There are two transactions. First T1 starts. When the T1 starts, immediately a record indicating the start of the transaction T1 is inserted into the log. Then immediately the T1 modifies the data item to 900. Because it is deferred modification, I don't require the old value. Now 600 becomes the 900. It is modified. Immediately the corresponding record will be inserted into the log. But the actual here what is happening is, one important thing to be noted is, if this is the database and this is data item A, originally 600, data item B, let us assume that it is 700 and C is equals to 200. When the transaction T1 modifies the data item A, old value is 600 and then the new value is 900, immediately there will be a log. Let us assume that this is the logbook or system log. An entry which looks like this will be made into this log, which indicates that T1 has modified data item A and the new modified value is 900. And actual writing by this transaction T1 onto the database is not yet taken place. Still the database contains the old value only. Actual update to the database is not yet performed. Then immediately T1 modifies the data item C and the new modified value is 800. Corresponding entry will be made into the logbook T1 C 800. Then let us assume that the T1 has completed all its operations and all the modifications have been written to the log, and it commits. When it commits, the record will be, this commit record will be entered into the log for this transaction T1. And now the actual update to the database will take place only after commit record is inserted into the log. That's why now the actual database modifications will occur, and A is going to be 900, so this becomes 900, and C is going to be 800. So this will become 800. Still B is 700 only. Now immediately, now T2 is started. When T2 is started, this record is inserted. When it modifies the data item B to the new value is, let us assume that the old value is 500, the new value is 700. Now it will not be updated in the database. First a record will be inserted into the log, system log, saying that T2 has modified B, the new value is 700. When the transaction T2 commits, only after that the database update will take place. Now this 500 will become 700, that is the new value of the modified value of the data item B. On failure, let us assume that if there is a failure, a transaction need to be redone if and only if the log contains both start and commit records for the transaction. Otherwise it need not be, we need not do anything, we don't have to take any action. And if you carefully observe, suppose let us assume that after doing this, after this much there is a problem, then what happens? For the transaction T1, how many transactions are there at the time of failure? Two transactions, T1 and T2. T2 has been started and committed. That means that after committed, the system might have tried to write the updates to the database. Hence, for the transaction which has both start and commit records in the log, we will be applying redo operation. That is why the updates made by this transaction T1 will be redone. What is redoing? Take the new value of the A and then take the new value of the C and then forcibly write it onto the database. That is called as redoing operation. And if you take this T2, that is the transaction T2, what has happened? T2 has modified the data item B, the new value is 700, but before commit it has failed. Then there is no problem for T2 because the actual update on the database will take place only after the commit state has been reached by the transaction T2. Hence, it has not. So, since there is no commit record for the T2 and it has failed in between, hence I do not have to take any action because it has not committed, it is not committed, and then the updates are not written to the database. Hence, do not do anything, or you can just ignore that. That means in deferred modification techniques, in the whenever there is a failure, we look at the log records and any transaction which has both start and commit records in the system log. Only for those transactions we will perform redo operation. That is, we will take the new value and then forcibly write it onto the database. For those transactions which have just started and then not committed and might have done some modifications, we do not have to worry because it is not yet committed. Hence, we should ignore such transactions. This is about the deferred modification technique. Let us have a look at this example. For this deferred modification, again the same thing. I have T1, T2 and T3. T1 is started, T1 modifies A, new value is 900, T1 modifies C, then it commits. After it commits, the actual updates to the database will take place, and then T2 is started, it modifies B, it commits, and after it commits, the actual update to the database for data item B will take place. Then T3 starts and it modifies the data item C, and there is a failure. That means it has not committed. Now tell me what transactions need to be redone? Because in deferred modification only redo operation is required. We never require undo operation. Hence, in the log records which indicate the modifications, we find only the new value. I have T1, T2 and T3. These are the transactions. T1 we find both start and commit. Hence, we need to redo the operations of T1, modifications of T1. And if you look at T2, T2 also has start and commit records or entries in the system log. Hence, redo it. But for T3, if you carefully observe, in the system log I have only the start record, T3 start, and I do not find any commit record. Hence, I do not have to take any action with respect to the transaction T3 because it is not committed, the system has not tried to write the modifications of T3 onto the database. Hence, ignore. Only for T2 and T3 I apply redo operations. In defer modification, I never use the undo operation. Hence, I always require only the new values of the data items. Now, let us have a look at this immediate database modification technique. Under log based recovery, the first approach is deferred modification, which we have discussed just now, and the second approach is immediate database modification. It is exactly opposite to the deferred modification. There is no postponement, and whenever a transaction modifies the data item, before it commits, the updates will be applied onto the database. This is immediate database modification. In this, database modifications to be output to the database while the transaction is still in active state. If such is the case, for incomplete transactions on failure, undo operation is needed, and for the committed transactions, redo may be applied. Let us have a look at this. That is, T1 has started, T1 has modified A, old value is 600, new value is 900. Immediately, without waiting for the transaction to commit, the updates are made to the database. Then T1 modifies C with these values, and immediately after that the updates will be made onto the database. Then the T1 commits. The commit record will be inserted into the log. Then T2 starts and T2 modifies B and T2 commits. And let us assume that if there is a failure here, then in immediate modification, when a transaction fails, we will need both redo and undo operations in immediate modification case. If a transaction fails in between, we will be applying undo operations. If a transaction is committed and there is a failure, we will be applying redo operations. So that's why when there is a failure, for those transactions which have been started and which have been committed, then it indicates that the system has already tried to modify the database, and all the information about the modifications has been recorded onto the persistent storage permanently. Hence, for those transactions I will be applying redo operations, and for those transactions where it is started and it has modified some data item, before commit it has failed. For such transactions I will be applying undo operations because it has not committed. So I will be taking the old value and then performing undo operations for those data items. Hence, for a transaction with start and commit records, I apply redo. For transactions with start record alone, I will commit undo operation. Both redo and undo are required in immediate modification technique. Let us have a look at this example. T1 is started, T1 modifies A, immediately that update is written to the database, and T1 modifies C, immediately that is written to the database, T1 commits. And T2 starts, T2 modifies B, it is written to the database, T2 commits. T3 starts, T3 modifies C, it is modified on the database, it is tried, actually at least the system has tried to modify the database, immediately there is a failure. In such case, you find out with the help of the log record which are the transactions which are started and committed, and T1 is started and then committed, hence apply redo. T2 has been started and committed, hence apply redo. But the T3 is the transaction which is started, but there is no corresponding commit record for the transaction. So that's why for such transaction you apply undo operations, and this is how we recover from a crash with this immediate modification technique. In this we require both redo and undo operations. Now one more important concept in log based recovery is checkpointing. In case of failure, the log needs to be searched to determine the transactions that need to be redone or undone depending on the approach or technique we are adopting. But this searching is time consuming, and most of the time the algorithm will redo the transactions which actually written their updates to the database properly. Redoing them is waste of time. In order to reduce this kind of overheads, checkpointing is helpful. Checkpointing concept has been introduced. Now let us try to understand what is this checkpointing. It is analogous to what we see in accounts departments while auditing is done. Let us assume that in an organization, an accounts department maintains accounts, and the proper auditing will be done where a team of auditors will visit the accounts department and they will thoroughly check all the transactions that are in the accounts department and the entries in the account books, and if everything is found okay, they will put a seal saying that up to this, on this so and so date, the auditing is done and it is found okay. Let us assume that the accounting is being done from 2008 January. In December 2008, the auditor's team has visited the accounts department, they have performed auditing activity and they found everything okay, and then they have put a seal, audit okay. Then again in February 2010, auditors have come and then they okayed it. It is auditing is okay in February up to February 2010. Again in October 2010, auditing is done, and again in February 2012, auditing is done, and again let us assume that in July 2012, if the new auditors team comes, then from where they have to check the accounts, they don't have to look from the beginning, they don't have to look for the correctness of the accounts, accountancy from the beginning. They will go back to the latest checkpointing or auditing point, that is the February 2012. Let us assume that it is 29th February 2012, and from then onwards they will properly look at the transactions and entries in the account books, and they don't have to go back to 2008, since it is understood that since there is a seal or some certificate given by auditing department which has audited the accounts in February 2012, 29th of February 2012, everything is assumed that it is perfect. That means whenever a subsequent visit happens by this auditing team or some other auditing team, they don't have to go back, and they need to only start from the 1st of March of 2012, okay, and look at the entries made in the accounts books. Okay, that means if this kind of audit certificate is not there, okay, then what happens? If a new auditor's team comes in 2012 July, what happens? They will have to again start from the January 2008, which is cumbersome, laborious, and then waste of time. Hence, the similar kind of concept is also being used in log based recovery, that is called as checkpointing, which is going to reduce the overhead of revisiting all the transactions and then redoing them when there is a failure occurring in the system. Here we have T1, T2, T3. T3 starts, let us assume that there are so many other transactions are also available before this. T1 starts, T1 modifies D. Let us assume that there is only one value, that is new value. The approach used here is the deferred modification technique. It is deferred modification. In deferred modification technique, I require only new value. I never require the old value of the data item. Then T1 commits. Here at this point the checkpointing done. During this checkpointing, the system will make sure that all the modifications done by all the transactions which have been started before this up to that point are returned to the database permanently. All the transactions that have been started and then completed. For such transactions, the modifications will be permanently returned to the database, and all the logbooks are permanently stored on the stable storage, and a checkpointing entry is made. This indicates that at this point of time the checkpointing is done. Then T4 starts, T4 modifies B, T4 modifies A, T4 commits. T2 starts, T2 modifies B, and then T3 starts, then T3 modifies A, T2 modifies D, and let us assume that there is a problem here, the system crashes here. Then what need to be done? We need to take care of only those transactions which have been started or which have been just started before the checkpointing and which are not committed. So what are the transactions that are started and then not committed after checkpointing? The T4, T2 and T3. Out of this, T4 is committed, hence I will apply redo operation, because the approach I am using here is deferred modification approach. For T2 and T3, they have been started and then not committed, hence I do not have to take any action because it is deferred modification technique. That is why there could be 1 lakh entries in the logbook. Okay, I do not have to worry about all of them. I need to consider only those transactions which have been just started and then not completed during the checkpointing, that is those which have been started just before the checkpointing which are not committed, and those which are started and committed after the checkpointing. That means this becomes very simple when we recover from the failure. T2 and T3 are ignored because they did not reach their commit points. Because it is deferred modification, I should ignore T2 and T3. T4 is redone as it is commit record occurs after the latest checkpointing. T1 is committed before the latest checkpointing, hence no action need to be taken. That means whenever there is a failure, I need to take care of the recovery actions, that is redo or undo, only from the recent checkpointing. There could be 1 lakh or 2 lakh records in the system log before the checkpointing record. So I do not have to worry about them. I need to worry about only those which have been just started during the checkpointing or after the checkpointing. Now, what are the various actions or sequence of actions that have been taken up, that have been executed in checkpointing? First thing is output all records, that is log records currently in main memory onto the stable storage. Stable storage is the one where once you store the data, you will never lose it. Okay, there is no loss of data when you store data on the stable storage. That means first action is we need to write all the log records to the stable storage. then output all the modifications that are done to the buffer blocks to the disk blocks. Then output a record, log record, indicating the checkpointing onto the stable storage. And during the recovery process, the redo or undo operations for the transactions will be considered which occur after or just before the latest checkpointing record on the log. I don't have to start from the beginning. Here I am going to reduce lot of overhead due to searching for the transactions in the logbook and then redoing them unnecessarily. This is the use of the checkpointing. Now in recovery we have seen the log based recovery techniques, that is we have deferred modification and then immediate modification. Now we look at the another kind of recovery mechanism that is called as shadow paging, where we don't use the log records in case of a single transaction environment. Of course in multi-transaction environment, of course some amount of logging is required. This technique is an alternative to log based recovery method. We know that the database is partitioned into some fixed length blocks called as pages. These pages need not be in particular order on the disk. A page table is used to find the location of ith block. That means every database will be spread across some pages or the disk blocks, and they need not be contiguously located on the disk. In fact, they can be at different locations, but there will be a page table which will help us in locating the blocks pertaining to a database. In shadow paging technique, two page tables are used. The first is called as a current page table, the second is known as a shadow page table. When a transaction starts, both page tables are identical, that is in the beginning both are going to be identical. The shadow page table is never changed during the execution of the transaction. That is, whenever a transaction is under execution, whenever it modifies the data item, the shadow page table entries will not be changed. The current page table may be changed when a transaction performs a write operation. All input and output operations use current page table only. When a block page is modified, it is written onto the different location on the disk, and the old block which contains the older values are still available and can be accessed using shadow page table. This is sufficient to recover from the failure. This technique does not require a log, that is in case of a single transaction environment we don't require any log and we don't require redo and undo operations. Of course, because the multi-transaction environment is a more complex one, hence there you may require the logbook, but for single transaction environment we don't need any logs, no redo, no undo operations required. Let us have a look at the diagram which gives us some clear idea. This is the pages on the disk, this is the page table. Let us assume that the database requires only 5 pages, 1, 2, 3, 4, 5. This is the shadow page table, this is the current page table, and in the beginning of at the time of when you start the transaction, both shadow page and the current page table, they are identical. But when a transaction modifies a disk block or a page, automatically the current page table entries are modified, and whenever there is a failure and the older values of the data items or the blocks on the disk are still maintained or available with the shadow page, and we can always access the older values using the entries or the information available with the shadow page. This is how it works. Now let us have a look at some example. We assume that this is the disk and this is the current page table, and the disk contains disk blocks. Let us assume that in our example the database is spread across only 3 disk blocks, that is there are only 3 pages for the database. That is why the first page of the database, this is the second page of the database, this is the third page of the database, and physically on the disk they may be at different locations. In this case, first page is this one, second page is this one, and the third page is this one, and meaning that they need not be at contiguous locations on the disk. This is the situation or the status of current page table before a transaction starts. When we start a transaction, then what happens? We need to make a copy of the current page table and this copy is now called as a shadow page table. When the transaction is started, both the entries, that is the current page table and shadow page table, are identical. There is no difference. Okay, one is pointing to this and the shadow page table page 1 is also pointing to the same thing. They are identical. There is no difference. Let us assume that the disk block 104 contains data item B and disk block 108 contains data item A. This is the situation when a transaction begins. During the execution of a transaction, let us assume that the transaction modifies the data item B and it is some value, that is modifies the disk block at 104. Data item B is available where? It is available in the disk block 104. The transaction modifies some data item on disk block 104. Then whenever such modification or update takes place, the modifications are captured or only reflected in the current page table. The shadow page table entries are not modified at all. Okay. So page table 1 is same, but since the disk block 104 now is modified, now what it will do is, instead of writing the modified data values onto the same location, earlier it was 104. The page 2 of the database was pointing to 104. Now after modification, it will pick up or find a new location which is empty and then write that modified block onto that location. That is, instead of modifying the data item B which was at the 104 block, now it will write the block which is modified, that is the second page of the database which is a modified page, will be written to the disk block 121. Okay. Now the 104 is the disk block which again still contains the old value of the database. So this is how the shadow paging works. Let us assume that after this modification there is a system crash. Now when it is time to revert back to the previous data values or values of the data items, what I will do? I will discard the current page and then I will revert back to the shadow page. Since the shadow page is still pointing to the older data blocks and the values of the data items in those blocks are still containing the older values, hence I can always take the database to the previous consistent state using the shadow page. Now I will discard if there is a system crash, I will discard this current page and then revert back to the shadow page. Now that will become the current page and then I will again restart the transaction. And let us assume that there is the transaction is successfully executed. Then what I will do is, I will discard the shadow page and this current page, whatever is the modified one, that becomes the current page for the next transaction execution. This is how the shadow paging works. If you carefully observe, if it is a single transaction environment, I don't require the redo and undo operations or logbook. I am going to maintain the older values and the new values of the database in terms of the page tables. I have current page table, I have shadow page table, and whenever there is a modification, the current page table will point to the new location which contains the modified value of the data item. Still the old page, the shadow page table, will point to the older disk pages. This is how we recover from the failure using this shadow paging technique. In this session, we learnt what is the importance of recovery mechanism. It is needed whenever there is a failure during the execution of a transaction. We need to make sure that the state of the database is taken back to the previous or latest consistent state which was existent before the start of the transaction. To achieve that, we have these recovery mechanisms, and we have looked at various recovery strategies, that is log based recovery, where we will be using a system log to store the information related to the modifications done by various transactions, and whenever there is a failure, we will consult this system log and then revert back to the previous consistent state. We have seen deferred modification and immediate modification techniques, and in deferred modification techniques we use only redo operations, whereas in immediate modification techniques we need both undo and redo operations depending on the completeness or the committing of the transactions. The concept of checkpointing is understood properly with an example, and the other recovery mechanism, that is shadow paging, is also discussed in detail with an example. In shadow paging, we do not require redo and undo operations if it is a simple case of single transaction environment. Thank you very much.